Hello, how are you, my lovely students? Now I'll speak about the second part of the Unit 1, Lesson 1, Mass and Weight. In the last video, I spoke about the mass, and the mass is an amount of matter in an object, and it is a fixed value, which it doesn't change by changing the place. We also spoke about the measuring. We also spoke about the measuring units of mass, which are kilogram for big masses and gram for small masses, and the devices used to measure masses, which are balance scale for big masses and sensitive scale for small masses. Now I'll speak about the second part, which is the weight. To understand the concept of weight, you must answer this question. What makes objects fall down towards the Earth's surface? Like this ball, why does it fall down toward the Earth? Why? These girls fall down when they jump. Yes, there is a force pulling these objects down. This force, when affecting an object, is called weight. So we can define weight as the force by which the body is attracted to the earth, or define as the gravitational force which acts on an object's mass. How can we measure weight? Yes, by using spring scale. As you see in these figures, it consists of scale like this and two hooks. Top hook holds it, and the bottom hook is to hang the object. Also, spring scale has a spring which expands when hanging an object on it. This spring has a pointer. This is the pointer. This is the expansion due to add weight. Now the measuring unit of weight. Okay, before you know the measuring unit, you must listen to this short story about Newton to know why the measuring unit of weight is Newton. In the past, the scientist Newton was resting under an apple tree. When an apple fell on him, he thought for a long time, why did the apple fall down? Not go up or right or left. Why did it fall down? And made many activities to prove that the earth has gravity that attracts and pulls any object towards its center. And tell us this force which attracts the object's mass known as weight. So the measuring unit of weight is named after him. Now, you know the measuring unit of weight is called Newton. Newton is almost equal to the weight of an object whose mass is 100 grams. Or by easy meaning, when we take object its mass equal 100 gram and hang it on a spring scale, we find its weight equals 1 Newton. So 1 Newton equal 100 gram mass. Some notes. Firstly, the effect of weight is direct toward the center of the earth. Take care, toward the center of the earth, not surface. So it has a downward direction. The second note, on earth all objects have weight because there is gravity on earth. But in space all objects have no weight or weightless. Less means without. So weight less means without weight. Why? Because there is no gravity in the space. How can we measure weight? By using a spring scale. Yes. How? This object is hung on the scale so it pulls the spring downwards. The object is hung on the scale so it pulls the spring downwards, like this picture, and the reading of the pointer increases. The weight is determined by the extension of the spring. Now, the time of give reason. Question 1. The weight is a changing and variable property of an object. Pause this video and think with me. Because the weight of an object depends on gravity, which differs from a place to another. Second question. Weight is different from one planet to another. Of course, the same answer, because the weight of an object depends on gravity, which differs from a place to another. There are some factors affecting weight, which are: number 1, the object's mass; number 2, the place or the planet where the object exists; number 3, distance between the object and the center of the earth. Let's summarize these points in this diagram. Weight is affected by mass, place, and distance. Factor number 1, the object's mass. See the two balance scales. When increasing the amount of bananas, mass increases and the weight of object also increases. So, as the mass of an object increases, the weight increases. Now let's discover the relation between mass and weight by this activity. We made this activity by using a balance and spring scales. We bring different objects with different masses and measure their masses by the balance scale and write their mass in this table. Also, hang these objects on spring scale and record their weight. In the table, what do you observe? We observe that when mass increases from 1 to 5, the weight also increases. Second observation, weight in each case equal mass times 10. So we discovered this relation, which is very important. Weight, which is measured by Newton, equals mass, which is measured by kilogram, times 10. Take care, mass must be by kilogram, not gram. Also, we can calculate mass from this relation. Mass equal weight divided 10. Some examples on the last law. Relation between mass and weight. Example number 1. Calculate the mass of an object that its weight equals 90 Newton. Stop the video and try to answer it. It is very easy. Mass equal weight divided 10 equal 90 divided 10 equal 9 kilograms. Example number 2. The mass of an object is 5 kilograms. Calculate its mass on the moon, its weight on Earth. The answer, letter A or number E. The answer, you know from the previous video, mass of an object on the moon equals its mass on Earth. This equals 5 kilograms. So mass on moon equals 5 kilograms. To calculate weight on Earth, we used this relation. Weight equal mass by kilogram times 10. So weight equal 5 times 10 equal 50 Newton. Another example, an object's mass on Earth is equal to 6 kilograms. Calculate its mass on Moon and its weight on the Earth's surface. It is so easy. Mass on Moon equal mass on Earth equal 6 kilograms. Okay, weight on Earth. To calculate weight on Earth, use this relation. Weight on Earth equal mass by kilogram times 10 equals 6 times 10 equals 60 Newton. Take care to calculate weight. The mass must be measured by kilogram. The last example about this point. The mass of an amount of milk equals 300 grams. Calculate its weight. Think with me how to solve this problem. The mass equals 300 grams, not kilograms. So, firstly, the mass must be changed into kilograms before calculating the weight of the object. So, mass equals 300 divided 1000 equal 0.3 kilograms. And weight equal mass by kilogram times 10, so equal 0.3 times 10 equals 3 Newton. The second factor which affects the weight is the place or the planet on which the object exists. You see that Jupiter, Earth, and Moon. Moon isn't planet, but is a place different than Earth. Okay, Jupiter is the biggest planet, so its mass is bigger than Moon and Earth. So the attraction and the gravity of Jupiter bigger than the gravity of Earth and the gravity of Moon. And you know the weight of an object depends on the gravity of the place. So the weight of object on Jupiter is bigger than its weight on Earth and bigger than its weight on Moon. So when the mass of the planet increases, the gravitational force increases. So the weight of the object will increase. We also found that the weight of the object on the Moon's surface equals 1/6 of its weight on the Earth's surface. So we can calculate the weight of object on Moon by this relation. The weight on the Moon's surface equal weight on Earth's surface divided 6. It is a very important relation, and we solve many problems by this law. Also, we can calculate the weight of an object on Earth when you know its weight on Moon. By this relation, weight on Earth equals weight on Moon times 6. As you see in these pictures, in the first one, the weight of this person on Earth equals 1,200 Newton. So his weight on Moon equals 200 Newton. Second picture, weight of this doll equals 30 Newton on Earth. So its weight on Moon equals 5 Newton. Another example, this boy, his weight on Earth equals 360 Newton. So its weight on Moon equals 60 Newton. 360 divided 6 equals 60 Newton. Okay? Also, the weight of this juice equals 12 Newton on Earth. So its weight equals 2 Newton on the Moon. 6 of its weight on Earth. Okay? The weight of this pink bear on Moon is 3 Newton. So its weight on Earth equals, excellent, 18 Newton. Because weight on Earth equals 6 times weight on Moon. The weight of these apples on Earth is equals 6 Newton. So its weight on Moon equals, yes, 6 of its weight on Earth. So equals 1 Newton. Okay, now some examples which can be found in any exam. Example 1. An object's mass on Earth equal 12 kilogram. Calculate number 1, the mass on the moon. Number 2, the weight on Earth. Number 3, the weight on the moon. Stop the video for some seconds and solve the problem. Number 1, mass on moon equals mass on Earth equals 12 kilogram. Number 2, the weight on Earth equals mass times 10 equals 120 Newton. Number 3, the weight on moon equal weight on Earth divided 6 equals 120 divided 6 equals 20 Newton. Another example, an object's weight on Earth's surface equals 360 Newton. Calculate number 1, its mass on Earth. Number 2, its mass on moon. Number 3, its weight on the moon. Think with me. The answer is number 1, mass on Earth equals weight divided 10 equals 360 divided 10 equals 36 kilograms. Number 2, mass on moon equal mass on Earth equal 36 kilograms. Number 3, weight on moon equal weight on Earth divided 6 equals 360 divided 6 equals 60 Newton. Now the time of give reason. The weight of a person on Earth's surface is larger than that moon's surface. You know the Earth is bigger than moon. So your answer must be because the mass and the gravity of Earth is larger than the moon. Now with the third factor, which affects the object's weight. The distance from the center of the Earth as the distance between the object and the center of the Earth increases. The gravitational force which attracts the body toward the center decreases, so weight of the object will decreases. Or in other words, the larger the distance, the smaller the gravity. Give reason, the weight of a person in a balloon is smaller than that on the Earth's surface. Stop the video for some seconds and answer the question. Review your answer with mine. The answer is because the distance between the body and the center of the Earth increases, so the gravitational force and weight of object decreases. Now, the last thing in this lesson. Comparison between mass and weight. Mass is the amount of matter in an object, while weight is the force which attracts the body to Earth. From the point of unit, the measuring units of mass is kilogram or gram, while Newton for weight. From the point of device, balance scale for mass while spring scale for weight. From the point of direction, mass has no direction while the weight has direction. which is toward the center of the earth. From the point of the effect of changing the place, mass is a constant value, so it doesn't change by changing the place, while the weight is variable value, so it changes by changing the place. I hope this lesson is easy, and I'll see you later in the next lesson to learn about the thermal energy. Thanks and goodbye.